Okay, boys, now that you've completed the example, had a look at the example on page 47 of the Unit 3 workbook, it's now time to have a go at our first exercise where we're looking at the reactions on a simple beam. We've got two forces there, a 500 Newton and a 100 Newton force coming down in the positions shown there of 2 meters, 2 meters, 2 meters. Now remember, the first thing that we've spoken about previously is that we can solve these using the three equations of equilibrium, where the sum of the vertical forces equals 0, sum of the horizontal forces equals 0, and the sum of the moments equal 0. So we're going to use the sum of the moments to start with and apply that to either the left-hand or right-hand support. I'm going to choose to do the left-hand support. So anything moving in the clockwise direction is going to be positive. So the sum of the moments about RL is equal to 0. We can now write each of the moments, remembering that moments is equal to force times distance. So 500 times 2 meters, 100 times 4 meters, and their reaction RR times 6 meters. The two top forces will tend to spin the beam around RL in a clockwise direction, therefore they'll be positive, where RR wants to spin the beam in the opposite direction, anti-clockwise, therefore it will be a negative value. So let's write that. (500 times 2 plus 100 times 4 plus a negative RR times 6 is equal to 0. That gives us 1000 plus 400 plus negative RR times 6 is equal to 0. The 1400 we want to get on the other side. We can leave negative RR times 6 is equal to, that becomes a negative value, so we have negative 1400. I want to get RR by itself, so we have to divide the 6 by both sides. In the same step, I'm going to turn the RR into a positive, so therefore we'd have to do that to the other side, change value to a positive there. So RR becomes 1400 divided by 6 equals 233.33 newtons. As it is at a positive value, it means that our arrow stays in the same direction. We don't have to change anything, and we know that that's going up. So there we have RR solved. We now would like to solve RL. We could do another moment about RR, but a quicker way is to look at the sum of the vertical forces. There are no horizontal forces in this case, so we don't have to consider that. If I say that all forces going down are positive, the sum of the forces vertical equals 0. If we look at all our forces, we can say negative RL plus 500 plus 100 minus RR, it's going up, its value is given there, 233.33 is equal to 0. Negative RL is equal to, the 600 will go over and become negative, and that will turn that into plus 233, gives me a value of 366.67. RL equals negative 366.67. Therefore, if we want to write that as an arrow direction, we can say RL is equal to 366.67 in that direction. So there we have it, guys. We've solved the left and the right hand reaction. Have a go at exercise 2, 3, and 4, please.